how to use StatCrunch to get simulation. This is part of our objective in this course, which is to use simulation to provide probability analysis. Now, what do we mean by probability analysis? I interpret that to mean simply finding probabilities and maybe discovering some of the laws like the addition rule and the multiplication rule. I'm not sure about discovering them, but maybe we can calculate them using simulations or approximate them. Now, if you've read anything about simulations, what we're doing is actually generating a sample. Okay, and we know that frequencies, sampling frequencies, specifically relative frequencies, approximate the underlying probability. So if we have an experiment that we're trying to calculate the probability for, we just repeat that experiment a lot of times and take their relative frequencies to represent their the associated probability. If you know about the law of large numbers, that implies that as the sample size gets larger, the relative frequency approximates better the corresponding probability. So let's take an experiment that we can do with StatCrunch simulation. What I want to do is I have an urn that contains 5 red and green balls, and I want to choose 7 of those balls at random from the urn. Of course, when you say at random, that means every ball has an equal chance of being selected. And by without replacement, we mean that once the ball is chosen, it's not put back into the urn to be selected again. Now, what we want to do is repeat this experiment. That means each time we start out with 13 balls, 5 of red and 8 of green, and we're going to simulate randomly selecting 7 of them and count the number of red balls. And we want to see if we can therefore estimate what the probability of more red than green is going to be. Now, in StatCrunch, there's a number of atlas that have been created for us, and the atlas we're looking for are under simulation, and conveniently there is one for urn sampling. And we can conveniently have 5 red, as it says there, and we can adjust the number of green to be 8. And as the problem states, we're going to draw 7 balls. Now, what we want to have is those occurrences where the number of red balls chosen is greater than the number of green chosen. Well, that can happen if you have 7 balls drawn. That can happen if 4 of them are red and only 3 are green, or if 5 are red and only 2 are green. And therefore, we have this constraint, greater equal 4. Now, you have to be careful. Sometimes you run out of red balls and you can't do it. All right, but in this case, we can do both 4 and 5. Okay, and I'm going to call this conveniently, give it a title of probability that number of red is greater than number of green. And now I'm going to compute it. Now we get to this screen here that's going to do the simulation. And we can just run it once. We can run it 5. We can run it 1,000 times. Now, as I said, by the law of large numbers, the greater your sample size, the better it approximates the probability. So let's go for the big one, 1,000, and let's generate that. So it's going to do that, and you have the histogram of frequencies that counts the number of red that are in the sample. So for 0, we had a few samples. There were a sample of 7 that had no red balls in it. We had a sample. We had 70 of the runs had 1. 324 times that we did the experiment, we had exactly 2 come out. 419 of them, we had red, 3. And now we get to the ones that are interesting. We had 161 of the experiments result in 4 red balls chosen, and 19 of them had the number of red balls equal to 5. So these two added together give us the count of those number of times we did the experiment where the result had more than 4 or 5 red balls, or more red than green. And that was out of 1,000, so that means the proportion or relative frequency is 0.18. And therefore, that is our approximation for the probability of getting more red than green. Now, as I said, we can get better approximations by even increasing the sample size. And we can do that by doing another 1,000 runs. So let's do that. What happens is StatCrunch adds that to the previous 1,000, and now the proportion is 0.1825. Do it again, and now it's 0.797. Now, why did it go down? The reason it went down is there's probability running around. We're doing a simulation, but we're using a random number generator, and in these cases, for the last 1,000 runs, we had much fewer instances of having more red than green. Do that one more time, and we get 0.797. All right, and now we can also, if we want to, we can add the results. These are the runs, and this is what we got, and we can add those runs to our spreadsheet by clicking Analyze, and it puts the number of red balls we had for all 4,000 repeats of the experiment in here. Okay, so as a final thing, we can actually calculate this probability when we learn about combinatorics, and I will show that in a post for Module 6 when we do combinatorics. And the exact number, exact probability, that red is greater than green, that's not going to show up. The exact probability that red is greater than green, I'll make this bigger, is going to be equal to 0.17948,718. Okay, so this is a fairly involved probability to analyze strictly from analytics, and what we did was instead do it by simulation. But now if your problem says provide the probability of the 4 decimal places, you're going to have to simulate a lot, and you really don't have an idea of when to stop simulating. Maybe when you see the convergence. Let's see what happens. I haven't tried this. Let's see what happens when I click this thing called convergence. This is showing you graphically what's going on. In the first 1,000, it kind of jumps, and it's kind of settling down to this number. If you put your cursor over it, it's telling you where it's going, and you can see that it's really settling down to a horizontal line. So you get a feel for when you might have 3 or 4 decimal places. Maybe we can view this I'm not seeing a way to view it, magnify this so we can see the jitter going up and down. But this gives you an idea of how to do this using simulation to do analysis. And like I'll do a OR example because we did the general addition rule. I'll do an OR example in the next video.